Now we want to take a look at a cubing function. Not only that, but it's cubing with a negative and a 1/2 coefficient. So let's see what we can do from here. So the main thing is to identify that this is x to the third. And so you recognize that your key shape is the cactus, right? And what am I doing here? Well, there's nothing inside the function because it's just x to the third. I got this plus 2 out here, so that means I'm moving this shape up 2 units. And what about the rest of it? Well, this 1/2 is going to indicate a compression by a factor of 1/2. Well, not only that, but you have this negative in front. So that means that we need to reflect across the x-axis. So when I reflect across the x-axis, it's going to turn this cactus shape upside down like that. There's going to be a compression, so we're going to squeeze it in a little bit vertically. And we're going to be moving up 2 units. So starting off with the up 2, I'm going to be right here. And I'm going to dash my new set of x and y axes. Alright, so this is 0, 1, 2, 3. Let's get those key points. So understand that since I've gone up 2, I don't need to worry about that anymore. What I do need to pay attention to is that I've got this negative and the 1/2. So normally, we would just cube these values, right? 1 cubed would be up 1. But it's a negative and it's upside down, so it's going to be down 1/2, so it's going to be like right here. When I do 2, 2 cubed is 8. So I'd go negative, I'd go down 8 units. But I've got the 1/2 as well, so half of 8 is 1, 2, 3, 4, like that. And if I try to do 3, 3 to the third is 27, half of 27 is 13.5, and that's just not going to fit here. But I can copy these points on the other side. So negative 1, if I come over here to negative 1, negative 1 cubed would be negative 1. The negative makes it go up, but then I do half of it. Over here at negative 2 cubed would be negative 8. Negative makes it go up 8, but the half is going to cut that, so it's going to be up 1, 2, 3, 4. And so it's still like a cactus shape, but it's turned upside down, and it has just ever so slightly a compression to it. So there we have it. All right, one more guy right here. F of x is equal to negative 5/3 times the absolute value of the quantity x plus 2 plus 8. The absolute value tells us the shape is a V. Inside, I see a plus 2. I do the opposite of that because it's inside. So horizontally I'm going to move left 2. The plus 8 that I see out here, I'm going to do exactly what that says. So it's going to be up 8. And then this negative 5/3. So I know that I'm going to be upside down. So that's just your reflection across the x-axis. And the 5/3, even though it's a fraction, is an improper fraction. So it's actually going to cause us to have a stretch by that 5/3 factor. Now, I'm not typically going to put a fraction like 5/3 in front of these functions unless it's something like absolute value, because absolute value is made up of those straight pieces. So it's really easy to not really do a stretch of 5/3 as much as we are doing a slope of 5/3. All right, so starting off, we are left 2 and up 8. And let's draw our new x-axis through here, our new y-axis, and let's get other points. So again, at this point, I've already done left 2, up 8. I'm done with that. I now need to use that negative 5/3. And again, since this is absolute value, you can just use that like a slope. So from here, go down 5 and over 3. Down 5 and over 3, and you keep going until you run out of room. Now, you do have a line of symmetry, so you can go down 5, not just to the right 3, but also to the left 3. Do that again, down 5 to the left 3. Now, if we do this right, everything lines up, and you have these two linear segments that make up your absolute value function. Line it up, knock it down, just like that. Well, that's pretty nice, pretty neat, and that's one of the things I like. I can use my straight edge for those absolute values, and it knocks it out pretty quickly. All right, and notice this 5/3 is a little bit steeper, because if I did a normal coefficient of 1, I'd be going down 1 over 1 like this. So having that 5/3, something that is like 1 2/3, is really close to 2, it definitely makes our graph steeper. So this is what it would have been without the 5/3, so you can get a sense of that vertical stretch that you have going on. All right, we got one more problem to do. Okay, and let's see what that looks like. All right, so here we have f of x is equal to 1/4 the quantity x minus 4 squared. So right away, we see the square. We know that we have a parabola. We see we have something inside the square. So it's a horizontal shift, opposite of what you see. I see minus 4. I'm going to go to the right 4. And then I've got that 1/4. So I don't have any shift up or down. I don't have a reflection, but I do have this 1/4, which is going to cause me to have a pretty significant compression. So that's a compression by a factor of 1/4. Now, if you have a hard time identifying how that compression is going to work, then I suggest you draw a new set of x and y values. Okay, I don't mean where it's been shifted to the right 4. I mean looking something like this. So if I plug in x, and I'm looking at y is equal to x squared, right? So 0 gives me 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on, right? I'm going to add a few more levels to this, just because of what's going to happen. All right, so let's see what happens whenever I apply that 1/4. So now when I look at y is equal to 1/4 x squared, I'm going to take each of these output values and multiply times 1/4. In other words, divide by 4. So 0 over 4 is 0. 1 over 4 is just that, 1 over 4. 4 over 4 gives me 1. 9 over 4, well, if we're going to try to plot this, we need to convert it to a mixed number. So 4 goes into 9 twice with a remainder of 1, so 2 and a 4th. 16 over 4 gives me 4, and finally 25 over 4. That reduces, well, it is reduced, but it can be converted to a mixed number, and that's going to be 6 and 1/4. All right, so your key points. You're going to the right 4, so you're right here. And we dash out our new set of x and y axes. This is 0, 1, 2, 3, 4, and so on. Right, just kind of mark over those guys because I don't care what they were on the original x-axis. I'm now basing this off of my new vertex. Again, normally I would have said this. 1 squared is 1, 2 squared is 4, 3 squared is 9. But that 1/4 says take all of those heights that you had and multiply that times a 4th. So I'm going to be up a quarter. 4 divided by 4 is 1. 9 divided by 4 is 2 and a quarter, which is why I've got this little chart over here to follow. If I go up 4 units, 4 squared is 16. 16 divided by 4 is 4. So 1, 2, 3, 4. 5 squared is 25. So it normally wouldn't fit on the chart, but then I divide it by 4 because of this 1/4, and I get 6 and a quarter, like that. So you can see that this guy is quite a bit compressed compared to the original one. Again, this vertical line going through the vertex acts as a line of symmetry, so I can copy these points on the other side. So there's the 1/4, 1, 2 1/4, 4, 6 1/4. If I go one more step, if I were to do 6, now I'm not going to do 6 out here because I'd run out of room, but over here I can do 6. 6 squared is 36, and 36 divided by 4 gives me 9. And so now I have all of these nice, gorgeous points to help me graph my parabola. So there we go. So the 1/4 was kind of tricky, but when you compare it to x squared without, you can see how it is quite a bit compressed. Now I know a lot of students say, "Oh, it makes it wider." I don't want to look at it that way. Look at it in a vertical perspective, vertical change. You are compressing that. You're squeezing it down. And you get that shape right there. All right, so now jump into the homework and see what you guys can do.